In today's episode,
telling the client, go away, go away, go away.
grab your laptops. We're chasing a rogue wireless device performing illegal activity.
And then we went hunting.
I have several questions at that point. You cannot prevent someone from screaming unless you neutralize that person.
Almost like a movie story.
Deauthenticate, deauthenticate, deauthenticate.
Welcome to Cisco TAC Stories. A podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Hello and welcome to the Cisco TAC Stories podcast, a podcast where we interview CX experts who tell us the crazy stories and interesting troubleshooting experience, and we learn together about old technologies.
Today we're welcoming Tiago Antunes, a technical leader in wireless from our most recent Lisbon office. Hello, Tiago.
Hi, thank you, Nico. Thank you, Tristan. Yes, my name is Tiago Antunes. I'm a technical leader in wireless in Europe. Actually, I joined Cisco in 2007, so a long time ago. I joined in Brussels TAC as a graduate. I did all my career in wireless. I was in Belgium until end of 2018. I moved to Portugal 2019, and I've been in CX Lisbon Center since then, supporting wireless technology.
Cool. Glad to meet you. So, Tiago, what story do you have for us today?
Yeah, so Nico asked me if I had some funny stories about wireless. We are both from wireless, so we kind of share same stories, but there is one that I think it was only with me. It's about containment, rogue containment.
Containment. Well, what is it?
So containment, actually, it's illegal in some countries. Containment is when you tell your access point to break the connectivity between other access points and their clients. So imagine you are at your home and your network is not very good. You can try to disrupt the neighbor network using containment. But again, this is illegal in some countries. So, for example, with Catalyst Center, where you can manage wireless access points and controllers, as soon as you enable containment, you get a warning message. This is illegal. This may be illegal in some countries, so verify the law in your country before enabling it.
And why would a feature like this exist in the first place?
That's a very good question. If you have like an event, for example, and you want only authorized devices to broadcast a Wi-Fi network, you may use containment in your premises to make sure that no external device is brought into the venue and starts broadcasting the signal, which will interfere with your network that you want to provide to your guests.
Interesting. And so the story that you have revolves around that, right?
Involves containment. So it's like a TAC case. Like all TAC cases generally start like my Wi-Fi is not working. So this happened several years ago, and it was a warehouse. Customer was having a warehouse, and he was complaining that the network was not working during business hours. So, like any case, we started troubleshooting, and we started to see that clients were getting disconnected very frequently, and it was happening mostly on one part of the warehouse. We did the initial troubleshooting, the initial debugs, and we could not really spot what was causing the clients to constantly reconnecting. When this happens in wireless, it turns out that, okay, as last resort, we need to do over-the-air captures.
Correct me if I'm wrong, Tiago, but at that stage, there's nothing in the logs, right? If that happens, Normally, a disconnection, you might see it in the logs, but here there was nothing at all, right?
No, so we were not seeing disconnections triggered from the wireless infrastructure. We were seeing just the client restarting its own connection. So it's like usually when this happens, that is because the client does not like, let's say, does not like the current connection it is. Like it's getting too many retransmissions, the too slow transmission data rates. So it decides to restart its connection. And this was, again, only in one part of the building. So the next, let's say, expect and common troubleshooting step is to, okay, let's see what happens over the air. And for this, we have over the air captures that we can collect. In Cisco wireless infrastructure, we can even put the access points in sniffer mode. And in that way, use our wireless infrastructure to do these over the air captures. So we did, and we got the customer doing the over-air captures initially alone on his own, and after he sent us the captures, we saw the authentication packets being sent by another device, and this is the common pattern of rogue containment. So when there's rogue containment happening, what the device does, the access point, is sending the authentication frames towards the client, telling the client, go away, go away, go away. And this disrupts the connectivity. So it looked like there was some device telling our customer client to disconnect. So we needed to find where these devices were. And it was very fun. That's why I chose this story. I asked customer if we could do it a live troubleshooting session. So customer was sharing his PC with a Wi-Fi connection over WebEx and doing an over-air capture. So we could see in real time the device sending the authentication frames, and we could see the RSSI or the signal. And then we went hunting. So
I have several questions at that point. The authentication frame in the capture, you can see who's sending it, right? There's a MAC address field.
yes. So we could see it was not a Cisco device sending these frames, but they were targeting our clients, the customer clients.
And so the intent is really to find where it is, right? Playing a game of hot and cold, like you're getting warmer, that's the intent of this one. Okay.
Yes.
Literally hunting.
Exactly. So we went hunting for this device. Literally hunting. So I was just steering customers. The customer was walking around with his laptop in his hands, sharing his screen with me, where we could see the over-the-air capture on his PC. And I was checking the RSSI, the signal of these packets. If the signal was getting lower, I was telling, okay, stop, go back, go left, go right. And we went around until he says, okay, I'm in the corner of the building. So the signal comes from the warehouse nearby. And I said, okay, let's go outside to see if we see this device outside. Customer went outside and we continue. And then he said, oh, you know what? That warehouse door is open. Let me see if there's someone inside. He went and there was no.
So this was the neighbors.
Yes.
This was the neighbor's warehouse, right?
So
not the same company.
It was a different company, another warehouse, but it was empty. So there was no one there, but the door was open. So customer went inside and we continue our hunting. So again, left, right, front, back, until he reached a small room. It was like a storage room. He entered storage room, and there it was, an access point from another vendor, still connected and plugged. And the signal was very strong at that point, at that place. So there was no one in the building. I told customer, well, if there's no one there, if maybe they forgot the device there, just unplug it and let's see. Customer unplugged that access point and bam. We stopped seeing those deauthentication frames over the air. We went back to the warehouse of the customer. He did a lot of testing around and problem resolved. So it was another company left some device behind connected doing rogue containment that was breaking connectivity to that customer that we had.
Wow.
So again, this was illegal, but of course, I don't know if there were any legal actions done afterwards. But it was a very fun and interesting case.
Yeah, it is. And in fact, it raises a question for me because this was a different company, right? So they were using different Wi-Fi network, Wi-Fi SSIDs, right? So how come a device on SSID A can disconnect a device on SSID B? Like I thought that it would be a device on the same Wi-Fi network would be able to disconnect you, but not the one from the neighbor.
Yeah, that's why it's illegal in some countries to use rogue containment, because you can use your own device to send frames to a client, because your rogue containment works with the detection first. So when the detection is happening, access points are hearing the air. They are hearing other SSIDs, and they see clients connecting to those SSIDs on the same channel, because an AP can hear other devices on the channel they are. The rogue detection, so the AP is a few seconds or milliseconds on each channel, scanning the air and detects if there are other SSIDs, other clients around. And after identifying, the rogue containment works in the way that it sends the authentication frames to those clients, telling deauthenticate, deauthenticate, deauthenticate.
No, I think it's important to note that this is only possible on WPA2 or less secure SSIDs. WPA3 does not allow to do this. So the authentication frames are clear text even in WPA2. But okay, now we have an option also on WPA2 called PMF. But WPA3, everything's encrypted, and an attacker could not encrypt the authentication frame properly to do that. So it sounds like a security concern, and you're right, Tristan. It is. That's why WPA3 came.
Tiago, do you know if this company was doing this on purpose, maybe maliciously?
Well, it's a good question, but the warehouse was empty. So my theory is that someone forgot the device there, and previously they saw this feature available on their device and they decided to turn it on. In my experience in TAC, I saw many customers enabling this even on Cisco devices without really knowing what it was doing. So yeah, it's a good question, but I'm not able to say if it was on purpose, maliciously, or just by mistake leaving the feature enabled.
People think it's magic, right? People think, oh, enable protection, yes.
Because you say that the building next door was empty, so it always makes me think like, it's an abandoned building and a spy would come and place an access point there just to, cause harm on that other company. It sounds like a really good, almost like a movie story.
Yeah, it was a very fun case.
It reminds me of something that I heard in different technologies as well. Like, that I'm coming from the cable service provider world, right? And where we have similar features, if you want, or features. But basically, those are actually for aviation radar detection, where when you realize that there might be leakage coming from your plane that might affect radar signal from airplanes, you should not be using that frequencies, right? And I heard, and I know that there is something similar in wireless as well, right? Isn't that a bit similar feature?
What you're referring in Wi-Fi is the DFS, on which the access points are hearing or listening the air on a certain channels called DFS channels,
DFS,
where
yes.
radars have priority. So an access point will only turn its radio on DFS channels if it does not hear radar. If it hears a radar signal, it will block that channel by default 30 minutes, and then we'll do a scan again to see if the channel is already usable or not. But there's no deauthentication here. Before transmitting, you hear the channel. If it's close to a radar, it will not use the channel.
But there it's a bit different because I assume that the access point doesn't understand the radar signal in itself. It just realizes that there is something at that frequency, which is a DFS frequency, and then just shuts down, right? It doesn't understand what's being transmitted, or does it?
Actually, the Cisco Wi-Fi, they have radar signatures. So each signal have a signature, like a Wi-Fi signature. It has been evolving and enhanced. Currently, it's very well. It's very good defined because previously it was very common to have false DFS detections. Now there are several mechanisms, like you need to detect the signal into the radios, because the access points have multiple radios, and the signature itself is very enhanced currently. So these false DFS detections are very low currently, because the signature is very well defined.
Oh, okay, so it means that if there is, let's say, a faulty device next to you emitting garbage on a frequency similar to DFS, then this would not kick in the DFS frequency deactivation, right? Okay.
No, it's very unlikely it will match the signature of a radar. It will be classified as an interferer or jammer device or whatever. There are different classifications. So we have these clean air technologies that the APs are hearing signals over the air, and depending on the signature of the in the spectrum, it can say if it's a microwave, if it's a jammer, if it's just an interferer, if it's a Bluetooth device, and so on.
I mean, maybe deviating a little bit from the scenario that you have, because what you mentioned initially was another access point, so talking Wi-Fi, right? So talking the same protocol, so you could see what was going on with a simple pickup, right? I guess.
Yes. Not a simple pickup, it's an over-the-air capture, because we need to capture the 11N frames.
Mm-hmm. Yeah, so it's basically one additional header in Wireshark, right? Okay. Yeah. But what do you do when you deal with jammers or with signals that are not standard Wi-Fi? Like, you want to see what this is?
Yeah. So I can introduce a different, let's say, not story, but user experience. Like in Cisco Live, in this event, there's a similar one, a technology event in Portugal, which is the Web Summit. In the Web Summit, other companies are invited to bring their products in the venue to show them. So it's very common they bring access points, they want to bring their Wi-Fi, and all of these devices they bring, some of them emit Wi-Fi. So we also do this hunting in Web Summit, for example. Web Summit itself, they have dedicated teams to go hunting for rogue devices, for interferer devices, and they do like that. So they don't use over-the-air captures, they use a spectrum analyzers, and they do this. They see there's a signal on a certain channel, and they go hunting left and right, back and forth, to see where the signal is getting stronger, until they find this device and they ask it to be shut down. It's very common in this big event. Cisco does not provide support in 2.4 gigahertz because you won't imagine the amount of devices that use 2.4 gigahertz and that break Wi-Fi. Wi-Fi becomes unusable on 2.4 gigahertz because all these devices. And in events where there are stages, they have all these lights going on, these microphones, and they only use 2.4 gigahertz. So Wi-Fi near stages on 2.4 gigahertz, it's unusable. Of course, those devices cannot be shut down, but we can clearly identify them in a spectrum analyzer that there are devices emitting signal on 2.4 gigahertz.
I'm actually surprised that we keep using this 2.4 gig spectrum. I know it's like it's an ISM band. So it's a band that anyone can use, and it's very narrow. So we need to deal with it, right? But when you have like production equipment, like a mic for a performer on stage, you don't want that mic to shut down, right? And I feel like using 2.4 gigahertz is a bit of a risk, right? Don't you think?
It is a risk, but you know how they do? They go over the maximum limit allowed of signal.
The power limit, you mean, right?
Yes. So on Wi-Fi we have power limits, but they don't use 11n protocol per se. So they go around this limitation. They use 2.4 gigahertz, but they just boost the power to make sure I will be heard. I don't care about anyone else. I want my signal to go through, and they will mess around with the 2.4 gigahertz.
I have a question on your Web Summit experience, and it comes from a story first. So I had a similar experience as your first story with a casino customer. They said, we are a casino. We took all the legal implication. We take responsibility. We do not want any rogue access points. So only our Wi-Fi needs to operate here. If there's anyone else bringing Wi-Fi inside the casino, it's an attempt at cheating or something. You could have, I guess, burglars coming and putting a wireless camera, leaving it somewhere to spy during the night, whatever, and they just don't want anything wireless in there. And they said, we want to have this rogue containment feature from our Cisco network activated and make sure there is no other Wi-Fi, which is definitely a legitimate use case. But I think in wireless, nothing is ever reliable. You cannot reliably prevent first, you cannot forbid them to transmit, right? The rogue devices will be able to transmit. It's a free medium. Like, you cannot prevent someone from screaming unless you neutralize that person. Same here. Unless you neutralize physically the device, it's going to transmit. The only thing you can do is send the authentication. So for sure, it's helping. It's disrupting the connection with the other device, but it's not 100% reliable. But this was a very controlled environment. In Web Summit or such large events, there's always some rogue Wi-Fi's, right? There's always an exhibitor. They have some random demo and they brought their own Wi-Fi access point. Like, what is your, you were on site. Don't tell me you were really hunting for every single device out there, right? You would need an army to do that.
So Web Summit has a team dedicated for hunting them. So it was kind of two ways. On one way, this team is always going around, or let's say proactive detection and mitigation. But there was the other way. So if someone is complaining the Wi-Fi is very bad at certain location, the first step is to go with this team with a spectrum analyzer there to see if there was rogues in that area, and in that case, they just identify them and tell them to shut them down. So there was the proactive and reactive mechanism. Of course, it's not 100% sure that all rogues were disabled, but it was like on the maximum as possible.
I think there's two aspects there, right? There's the RF usage. You want to prevent the rogues to use the RF space, right? Because they will kill your bandwidth. And then there's the security aspect, where depending on specific locations, you might want to prevent. Or if they try to copy your SSID, that could be a man in the middle, right? A honeypot. So I think we can configure rules to, and it depends also on your security level and what you want to tackle, right? It can vary a lot.
Yes. I think hearing you talk about this, I think we could also automate this maybe, like having a literally controlled, radio controlled car, RC car, looking for Wi-Fi signal that you want to kill, and we'll just, roam around the building, and then when it finds the,
Well, if you have the Wi-Fi deployed, your wireless infrastructure, you have access points all around. So the rogue detection happens that way. So your EPs, you can activate the rogue detection without the mitigation. You can just activate the detection to see on your building where there are rogues. Like you have clean air on your building where you have interferers. As long as you have the Wi-Fi infrastructure, you have already the devices there. In Web Summit, they had this dedicated team because, again, it's an additional, let's say, workforce that is available to go physically to the spots where the problem seems to be happening.
You need to negotiate with the people there as well, right? The robot cannot do that.
Yeah.
And sometimes the AP is put in a drawer or something, so the robot would not find it either. It will say where it is, but it's not going to help you.
And so we spoke a lot about 2.4 because it's a crap part of the spectrum, right? But what do we do? I mean, when I say we, I mean any vendor providing Wi-Fi access point and devices. What do we do to make sure that this does not happen on different frequencies, like the 5 gigahertz or other Wi-Fi bands that you might have? Because I guess eventually they will get filled in as well, and the same thing will happen there.
Yeah. The thing about 2.4 is that the frequency is lower. So the technology is much cheaper on 2.4 gigahertz than on 5 gigahertz, and even in 6. Because it's cheaper, that's where the most, let's say, like, for example, in Web Summit, it's startups, right? So they want to start with most of them with prototypes, and the costs are very high on 5 gigahertz, so they use 2.4. And in 2.4, the spectrum is shorter, so there's only these 13 channels, 3 non-overlapping. In 5 gigahertz, you have more spectrum available. So even if there are devices using your channel, you have much more channels available to move to. But the containment works the same way on 2.4 and 5 gigahertz. It's just 5 gigahertz is more expensive to use. So these IoT products that are developed, most of them start on 2.4 gigahertz.
Cool. Thank you.
Thanks a lot, Tiago.
You're welcome. It was fun to be here. Thank you for inviting me.
It was a pleasure to have you.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on Cisco Podcast Network and SoundCloud or in your favorite podcasting app. You can also find us on X at Cisco Tech Story without S. Thanks again for listening, and speak to you next month.
Searching signals hidden in the air. Don't tell me we can't find a way. Devices on the loose, we gotta clear this mess.